Hey, good evening. Welcome to Meteorology Lab. Not a whole lot going on the plains. You can see there's a little bit of elevated cumulus and some cirrus out around western Oklahoma there. But if we head to the charts, let me show you what we have on the SPC convective outlook. Yep, there's the 2% area, and the categorical forecast only has marginal across Iowa. So let me try taking you back to a time in May. I know this is really hard to picture, but imagine a May where we had supercells out in the Great Plains, nice, isolated, discrete supercells. And what we'll do is we'll go back to May 3rd of 1999, and I'm going to show you a look at the upper air charts so we can start getting acquainted with this a little bit. Now what we're seeing here, this is the United States. Let me draw that out for you. There it is right there, Texas, and then we have Florida, and then the Northeast U.S., the Great Lakes, and then the Northern Plains. And what we're seeing here, this is a 500 millibar heights and vorticity chart. And you can see that's for May 3rd of 1999. So what do we see here? We've got pretty significant troughing out to the west. This is 12Z. This is the morning of that deadly outbreak. We see a pretty strong shortwave moving through southwestern Utah and western Arizona. There it is right there. It appears there's also another shortwave moving across Colorado and Amarillo. And in between we can see a bit of ridging. And there's another trough right there. And keep in mind that the patterns are on the move. So all these waves are going to be heading eastward, which means, at least for a while, western Oklahoma is going to come under the influence of this subsidence right here, and then getting into some of the lift. Another thing that we see here is the jet stream. There it is coming out from the Pacific, then up through the central U.S., and the strongest winds are found right in this area here. So we've got a bit of channeled appearance to the vorticity patterns. There's the couplet of the anticyclonic center and the cyclonic center. So that forms a couplet, and that is typically right in between where we find the jet stream. Another feature that we have is a negative tilt trough. And I'm not too sure if the fact that it's negative has much bearing on things. I think we discussed this a couple weeks ago, but that probably indicates that some of the stronger dynamics are out to the west, perhaps. And let's see, what else do we have? Let's take a look at a few other charts. That's going to be tropopause data. This is the 1,000 through 500 millibar thickness and isobars. So this is identical to what we see when we do these charts. So what do we have back then? Well, we can easily do an analysis. The solid lines are going to be the isobars, and the dashed lines are the thickness. So there's the 540. So that's going to be the cold air up in the Pacific Northwest. So we can use this to get an idea where the fronts might be. I think perhaps the main Pacific front is way back there. You could probably make a case for a front being right around here, because you do have a little bit of a thickness gradient. In fact, we get a little box forming right there. But I find a lot of times when we have the main trough kind of extending down the plains around Amarillo to Midland, that's probably just lee side troughing and a dry line in place, and the main front is probably still way out to the west. So I think this probably suggests that the main front is in that area, and that kind of syncs up with that upper air analysis. You can see the main wave back in this area, and that probably supports that front right there in the Four Corners area. So the front is probably lagging the shortwave a little bit, and we've probably got a warm front in here somewhere. It's going to be very hard to place because 1,000 through 500 millibars is a very deep layer. But I would expect to find it maybe somewhere up in that area right there. And sometimes we find even weaker ones further to the south. And that's probably about all we can do with that chart there. Surface data is really what's important there. There's the 250 millibar analysis showing the troughing out on the west coast. And this one here shows the jet. So you can see the U.S. right down here, and offshore off the west coast, 130 knots, just off of Washington right there. And what else do we got here? 200 millibar analysis, 100, and let me see if I can find, let me just kind of dig through here. Just for those of you joining late, this is May 3rd, 1999. We're looking at some historical charts showing what it looked like on that day. Okay, that's the thickness, that's the hemispheric version of that. And let me see if I can find a good upper air analysis here. Here we go. Okay, there's our 850 millibar analysis for May 3rd. So we'll put that on the southwest U.S. and the Great Plains. And we have to keep in mind that the dew point plots here, these are dew point depression. So to actually get dew point, we have to subtract that value from the top number. So Amarillo, for example, here they're reporting a dew point of -9 Celsius. And then down here at Del Rio, that's a 15 Celsius dew point, so that's going to be around 59 Fahrenheit. Very rich air coming northward. So if I actually draw the values in, there's 15, there's 14, there's 8, and then there at Lawton, we had 8. 0 at Midland. Corpus Christi had 16. And then we get into dry air as we get out towards Louisiana there, so they're -4. And this X here, I believe, it's really been a while. I think that X means that the column is dry. So we're seeing a very deep moisture, mid-50s dew points up there at 850, coming all the way up from San Antonio up to Fort Worth, and heading straight for central and eastern Oklahoma. And we also see the low-level jet. 30-knot winds. If we do an ice attack analysis, this is going to be 30 knots here. This gives us an idea where the core of that low-level jet is there. Down here, 25 knots, 20 down in the Gulf Coast, so that puts the low-level jet pretty much right in this area. So that's where some of the stronger advection is going on, from Abilene up to Lawton there. And we'll go up to the next level, 700 millibars. Now we can check on the cap. We can see the cap there is surprisingly a bit weak. 4 to 5 Celsius up in Oklahoma City, and looks like 6s and 7s down there in Texas. And you can see that at 700 millibars we're under this very broad cyclonic flow. And then up at 500 millibars, you can see that strong troughing out to the west. And let me bring you up to 300 millibars. Now, my memory is a little bit hazy of some of these papers because this was 19 years ago. But I believe that there was a unresolved jet max kind of in this area here between radio sound stations. In fact, this AirEp, actually no, that's a satellite. That's a hang on, let me take a look here. Yeah, I think the stars here, I think those are satellite-derived winds. And we're showing 75 knots in between. So there's probably a very weak jet in between those stations, and that probably moved eastward during the day and affected conditions there in western Oklahoma. And the thinking was that the strong ageostrophic components across that circulation probably helped intensify the pressure falls and back the winds locally in this area here. Anyway, it would be nice to have some better radiosonde data, but I guess that's probably not going to be coming under the circumstances we have right now. Anyway, that's May 3rd, and that's kind of a look at a actual severe weather day. So let's head back into the current time. Okay. We do have some storms up there in Minnesota and the Dakotas, but these look like just multicellular. Looks like we have a front kind of extending southwest. Let's take a look at the theta analysis. And we can see some very strong potential temperature gradients right there. I'm not too sure where that front is. I might be going with something like that right there. I really would want to look at the surface data. In fact, we can certainly do that. Let me go and load up some surface plots in digital atmosphere. We can just go to retrieve data and bring that up. And this is the way we do the surface maps every evening. So there we are, processing the data, and it's ready to view. So the pressure analysis is going to look like this. So there's that front up there in the Dakotas. And then if we take a closer look, we can do the actual surface plots. And I'll give you the isobars here. Try that one more time. Okay, yeah, north winds across much of the Dakotas right there. And it looks like maybe the front is extending all the way down towards Texas there. So that right there is the cold front moving into Kansas, fairly dry. Dew points in advance of that front are only in the mid-50s, and we can see a absence of low clouds being reported in that moist sector. So moisture does appear to be a bit of a problem. Then where do we find the warm front? Well, the best way to do that is to start in the moist sector down to the south. You can see we've got 84, 56, 81, 60, 81, 58, pretty much the same. And now we get a little bit of backing and slightly cooler conditions there up in Iowa. So I'm probably going to go something like this for the warm front. And there's our cold front. So that's our basic analysis. And then the stuff going on up in the northern plains, that's going to be kind of a separate system. And I think a lot of the patterns there were actually put into place by this convection earlier today and yesterday. So I may not be able to do this very accurately, but it looks like there's a boundary right there. And we can see a strong temperature contrast between these two stations. So it looks like there's also a very important boundary right through that area. That appears to be some storm outflow there. So the best air mass, the triple point, appears to be there in southeastern South Dakota. And the moisture, looks like we get a little bit of pooling along that warm front, kind of in this area here. So synoptically, the better conditions are pretty much right in that wedge there in southeastern South Dakota. So here's the 250 millibar analysis, and we can see a big difference from that May 3rd map. We're under a cyclonic long wave pattern. So this is all painting out a, anticyclonic. This is kind of a big, very broad ridge across the western and central U.S. And embedded in that ridge are these troughs moving through the flow. So this one is helping to generate the stuff there in the Dakotas. And then after that passes, that's going to move into the Midwest tomorrow. And then we'll see this other ridge start to move into the plains. Quick look at the 700 millibar conditions shows things are very warm up there in the middle troposphere. We've got 10 to 13 Celsius, very hot conditions up at 850. So that's helping to keep things capped. Up where we do have the storms, 700 millibar temperatures are closer to 5 and 4 degrees. And then at 850 millibars, this is showing the dew point in temperature. And the dew points look very dry. Lots of values between 0 and 2 degrees Celsius. That's in the 30s. And I don't find anything much higher than that until we get into Arkansas and Missouri there. See, there's 8 and there's 9 at Omaha. But we're really hurting for moisture, at least moisture depth in Texas and the southern plains there. There's our surface map. Very strong cold front coming out of Canada. And we can see what happened to yesterday's front. Moved very quickly across Ontario and Quebec. So the storm track is running something like that right there. I think maybe some of the weaker systems, maybe the tail end of these systems, they are moving into the Great Plains. But we're definitely not getting the brunt of that cold air. That's way up there in the Labrador Sea area and around Baffin Island. The Gulf barely open. The isobar packing there, it's kind of confined to the inland locations of Texas. And then we'll take a quick look out in the Pacific there. Definitely got some cold, or yeah, that's cold air there, kind of a trough, thermal trough in that region. And that's suggesting that we do have a cold front which has moved into the California area. Maybe something like that right there. All right, this is probably a good time to take a look at chat and bring up the satellite. We'll give you the infrared imagery. All right, let's see here. Willie Greenway joining us, and Erica Baker, Coffeyville, Kansas, 82. Willie Greenway got the books, and appreciate the comments. Glad you are enjoying that text. Have fun with tech here, and Nathaniel Peets. Ron Chalfant had an earthquake 4.5 magnitude this morning. Yeah, that brings back some memories of Oklahoma there. Got Ryan there in Florida joining us, reporting hot and humid conditions. Low 90s already. Water spouts off the coast of East Florida. Getting to that time of year. Got Shirley Keast reporting 43 and rain in Michigan. Michelle Curlin is here. And Cthulhu and Carl Burkhoff and Dean Benedict up in northwest Pennsylvania reporting a beautiful day. Christian Flock checking in from Yukon, Oklahoma, reporting things are very nice in that area. Which is more dangerous, tornado on land or on the water? I don't know. I would say probably on land because of the debris issues. Tornadoes are very efficient at picking up especially man-made debris like tin from roofs, destroyed houses, trees and stuff like that, and even glass. That's a really huge problem there. But I think it probably also depends on the intensity and whether you're directly in the center of it. But they would both be bad, I would think. Mr. Manlet reporting a great last day of high school there. Congratulations, Kathy Vanas, Overland Park 81, Mamatis. Some good commentary there by Cthulhu there. Satellite-derived winds, that's where we have a analyst at the Weather Prediction Center. They estimate the height of the clouds, and they find cloud tags, and they use a special animation software tool that can give them the velocity at that level. And then they encode that data and feed that into the global weather analysis there. So that helps fill in some of the gaps where we don't have radiosonde data. And that can be very important offshore. And I'll give you an example from that May 3rd day. Let me go back to that. Yeah, you can see off the west coast here. Lots of upper air data. And these are coming from, I'm not going to be 100% sure about this. I believe that this is satellite data. Some of it is from airplanes. That's called ACARS or AirReps. Now, the reason I can't tell is because they use this code here, the star, and I've forgotten what the star means. It's been a while. I think maybe the squares are the AirReps. But in any case, we use both of those to fill in data offshore. And we don't have any radiosonde data out there. Back in the 60s, they used to have ships that were anchored out here, and they would do balloon launches back then, but the powers that be decided to get rid of that. And then the rest of this data that you see off the California coast, there's basically no data in this region right here. That comes from first guess fields from the models. So it looks at yesterday's model run, and then it feeds it into this analysis. And so basically we're using the past data, the past model data, to improve the current analysis where we don't have information. And it works pretty well, surprisingly. I think we're going to find those. Yeah, okay, yeah. The stars are definitely satellite data. Because I realize this is 850. This is up at 5,000 feet. There's not going to be any airplanes flying from Japan to Washington at 5,000 feet. So this is the 300 millibar analysis. This is up at 30,000 feet. And there we do see the ACARS reports. There's the squares. Those are from airplanes. So this one's at 28,000 feet. This one's at 31,000 feet. And this comes from the onboard flight management system. It's able to transmit that directly to AirInc, which is a company that handles air-to-ground communications, and then they feed that into the weather teletype system. So this data is out there. The university sites don't always plot it, which is a big problem. I like having all of that data available. But Digital Atmosphere will be able to plot that information, and there may be a couple of other sites out there that handle it as well. Tim knows his weather stuff. Yeah. Thanks, I appreciate that, Willie, and geography. Yeah, maps were my big thing when I was a kid. In fact, when I was 5 years old, I got $2 out of my piggy bank when we were moving to Europe. My dad was in the military, and I asked for a road atlas of Europe because I wanted to see what the geography of Europe looked like. It was kind of exotic, and yeah, I've always been into maps, definitely. Michelle Curlin, tornadoes are destructive, except it's nature's way of bringing the atmosphere into balance. It's probably a good way of thinking of it there. 66 in Ohio there from Mike Bexley. And I think I'm to the end of the chat there, so let's go ahead and keep things going. Start looking at the forecast data. Well, the first thing we should do is check in on those storms up there in the northern plains. So there they are, out around the Sioux Falls, Huron area, Aberdeen. We'll roll that forward. Looks like they'll just kind of be a disorganized cluster of storms moving into Minnesota later this evening, and that'll progress very rapidly eastward. It'll be moving into the Quad Cities and La Crosse, Wisconsin around 3 in the morning. And then behind that, just cold air advection working in behind this low pressure in Minnesota. That brings us to the NAM. Let's look at the upper level patterns. Current time is going to be right there, so there's that strong shortwave from the Dakotas down to Nebraska. There's the good lift out ahead of it, and there's that ridging building in behind it. Looks like one more shortwave up here in Saskatchewan, so that'll be moving down in behind this front, and that probably is not going to do much except keep the low clouds persisting across Minnesota there for a while. So things will move quickly eastward, and then as we head into tomorrow afternoon, looks like that wave is right there moving into Illinois. Strong lift out ahead of it, probably see an increase in the humidity and the temperature over the next day or so in Chicago there. Then the showers will roll through, and then we'll have a little bit of clearing coming in behind that. So we're going to be probably, conditions will probably be a little bit quiet here for a couple days. Looks like a few weak shortwaves moving over this ridge. And then finally the cyclonic flow starts moving onshore there out in the west U.S. And it looks like the first of that cyclonic flow will be making it out into the central plains around Friday. So by Friday we should see better organization of the storms out there in Kansas and wherever the low-level moisture is. Pretty good channeling out here in California, probably a very strong jet right there. So this is where you would want to use your 4-cell theory, which is in my books, or you can look it up on the internet, and that holds that the strongest upper level lift will be in that left front quadrant, and there should be some strong subsidence in the left rear quadrant right there. And because of the cyclonic flow there, anything on the other side is going to be kind of indeterminate here. Almost looks like a face there if you draw some eyeballs there. There we go. All right, so let's take a look at the surface data. Go to the GFS, and we'll bring up the dew point and see how things look over the next couple of days here. Let's see, going into Wednesday, you can see the moisture coming up into Texas. It is a bit weak. This is all 50s dew points. So we'll start getting some 60s up there in Texas, kind of shallow. We'll bring up a sounding there. You can see just how shallow that moisture is right there. Only extends up to about 940 millibars, so it's only about maybe 2,000 feet deep. and above that some very dry air. So if we get a lot of sunshine hitting the ground, it's going to kind of mix this column, and that's going to bring dry air down to the surface, moist air into the top parts of the boundary layer, and that'll bring the dew points down into the low 50s. So it could be another dry day tomorrow. That cold air will be coming southeastward there. Looks like the leading edge is moving into Oklahoma there. The best chance of rain is going to be where that moisture comes close to that boundary. So we're looking at maybe Missouri and far northeastern Oklahoma for some of the best potential. Maybe by afternoon, maybe around Tulsa, maybe something going on right there. And you can see the dry line there is not very well defined. Dew points on the moist side of that dry line looks like a lot of low 50s. Then going into Thursday, more moisture coming northward. Then by max heating, it's going to be looking like this here. So the moisture does look better. Looks like a lot of 60s flowing northward. Appears that front there in Kansas is lifted north as a warm front. So maybe a chance of severe weather in Nebraska around Grand Island, Hastings, Salina, where that moisture hits that warm front. And the dry line is starting to become a little more defined out on the high plains. However, because of the very strong cap, that probably means the best potential is going to be around I-70 northward. Then for Friday, another cold front coming south. There's the main wave right there. And then by max heating time, looks like we got a bit of an inverted trough there in northeast Kansas. And look how well defined that dry line is. So we're definitely getting some upper air support, probably very strong lee side troughing there in Colorado. In fact, there's the low pressure right there. So that's helping to shape the wind field, and best chances for severe weather looks like Kansas for Friday. Maybe around Salina, Great Bend, and then possibly along the dry line around Dodge City to Woodward, but that depends on how strong the cap is. And let's take a look at that cap. We'll take a look at Woodward. So this is along the dry line in the moist sector. And we can see some fairly deep moisture, but it is up a bit on the weak side. Looks like lots of upper 50s dew points. The cap does look a little bit weaker, but this weak moisture does have me a bit concerned. So that would mean high LCLs and reduced tornado potential. Now up around Stillwater, we'll get a little bit closer to the moisture axis here and look at the sounding. Dew point temperatures look a little bit better. This is low 60s dew points to upper 50s dew points. Looks like we're still a little bit capped out east. So let's see. We'll go with an 88 degree max temperature. And yeah, they're very capped there. This is all negative area. So I don't know if we can get a little bit of forcing to help back the winds there in northern Oklahoma and bring some of that deeper moisture northwest where the cap is weaker, like right in this area here. That would help a lot. And it could still happen. The GFS is not that great at resolving mesoscale details, so we'll just have to wait until Friday to see what's going on. But Friday could be a severe weather day. And possibly some upslope flow too around Goodland. Or, yeah, Goodland. So this whole area, probably some potential there. And then I think the cap will keep things shut down further south, and looks like the moisture field is kind of weak in the Texas Hill Country and around Abilene. Then Saturday, what happens on Saturday? Looks like that lee side trough develops a wave moving up the boundary. So it looks like by Saturday afternoon, there it is right there around Salina. And then by evening, it's around Kansas City. So you see that stable wave? That's an important skill when you're working with these charts during the spring, keeping track of those waves and being aware of the life cycle of these baroclinic systems. So that right there is a baroclinic system. So there will be probably some severe weather potential along that warm front right there. Moisture axis working its way up into Missouri. So probably some severe weather on Saturday in northern Missouri. And possibly along the cold front, though cold fronts are not especially favored because there tends to be a lot of undercutting of the cells. However, in northwest Oklahoma, could be something there along that dry line. Looks like a well-defined dry line right there. So maybe around Sealing to north of Enid to Alva. We'll keep an eye on that right there for Saturday. Then Sunday, that cold front will push southward. So there's the tail end of that system. Looks like the old surface system kind of moved eastward and kind of dissipated. Got better moisture coming northward, 70s, dew points coming all the way up to that front. So looks like rain chances will be going up towards the weekend. I don't know about severe weather potential. We'll have to see what the wind flow is doing aloft and check out the instability. Yeah, it looks like some fairly decent lapse rates. The wind flow does look pretty weak here. Only seeing about 30 to 40 knots aloft. See that right there? That's going to cut down the severe weather potential some, in spite of the recovered moisture there. Again, we're looking at Sunday here. And we can see here the significant tornado potential is very low. What are they going by here? Let's see here. The Cape is pretty high. Yeah, look at that. 5,000 Cape. Trying to figure out where they're getting that from. That LCL looks way over to the right. I would take that with a grain of salt. If I work this out by hand and have an afternoon temperature of about 88, I'm going to get a parcel a little bit more like that right there. That's really what's going on right there. So be very careful when you're using these computed numbers. That can really get you into some trouble there. Could be some upslope flow around Childress, maybe a few higher base storms in that area. Then for Monday, looks like stationary front lifts northward. So again, Oklahoma getting some storms there. Probably some potential there. Let's look at the winds on Monday. Still looking pretty weak. So that suggests clusters for the most part. I don't know, that low-level flow, let me bring that back. That looked interesting. Looked like the low-level flow was backed a little bit there in northwestern Oklahoma. See that 0 through 1 SRH? That could be enough to kind of pull things together a little bit. So Monday, that may have some potential. And then it looks like by Tuesday, front will be lifting back northward there into Kansas. And then for Wednesday, everything moving north towards Omaha. The dry line is still through Kansas. So whether anything gets going along that depends on the cap strength. Looks like another cold air mass getting together there in Canada. Moving on to the 17th. We have a low there in the Texas Panhandle. I think we're starting to get some help from the upper levels at this point. Yeah, this is looking all cyclonic now. The dry line looking very well defined in northwest Texas. This could be a storm day here in western Oklahoma. And possibly up in Iowa, maybe in Dakota, some storms. And then going into Friday the 18th, looks like a storm day also. See that well-defined dry slot there. You've got the moisture advecting southwestward there. You've got the cyclone right there in the Amarillo area. The well-defined dry line. So synoptically, this looks like a pretty good day here. Friday the 18th. That's going to be a date to keep an eye on. And like I said, we'll certainly open things up during the afternoon. I haven't really decided how I'm going to do these severe weather specials, but we'll definitely do something. What I might do is just kind of bring things up every 2 hours or so and do a detailed overview. Anyway, that next system will be pushing south, and it looks like we've got a cold pool there in Dallas, so it looks like things have kind of joined together into sort of an MCS. And then moisture is heading back into the high plains for the 21st, and we're starting to get kind of to the end of the run right there. Looks like some very strong Pacific air starting to move into the Rockies towards the end there. Very strong occluded system up there in the Dakotas, but it does look like the moisture is coming back north. But yeah, look at all this northeast flow in the Gulf. Something's going on down there. We were looking at that tropical system there. Looks like the GFS is still going for that. This is around the 24th or so. It's not moving it as north aggressively, but it does have some activity down there in the Western Caribbean. Okay, 43 minutes in. I guess that's about all I've got for tonight. Let me take a look at chat. Oh, good information from Carl Berghoff, the satellite-derived winds. I've got some video of that from the 1990s that I shot when I went to INSEP. If y'all want to see that, I can probably put that on. I don't know if any of it's actually current anymore, but it shows how they do that. Jeff Krob here, wind grids. I'm working on getting that up and running with some historical data. Very good program. David Lumbert has been studying weather much more than his own geological sciences. Yeah, that can get you into trouble, but it's good to hear. GFS FV3 looking quite interesting. I need to look more at that, definitely. Ryan Toomey's says you work with the weather, Jeff. You have an excuse to be late. Carl Berghoff asking how WindGrids computes the SCP and STP. We're going to go over that tomorrow. All that stuff. I'm going to do part 2 of that paper we looked at yesterday, and that goes more into the severe weather parameters and looks at all the different forecast parameters versus the convective modes, tornado intensity, and so on. So that'll be interesting. So we'll go into a bit of that on tomorrow's program. Anyway, thank you all for watching, and that'll do it for me. Have a good evening, and we'll see you tomorrow on Wednesday. Bye-bye.